So, we've talked about projectile motion. We did this problem here where a cat is rolling off of a table with a horizontal speed and lands on the ground. We eventually want to get to problems like this where an object is launched at an angle and goes through the air with this trajectory as shown by the dotted line. But we have to deal with this velocity, this initial velocity of the soccer ball. Here, we dealt with the initial velocity of the soccer ball, I'm sorry, of the cat. It's horizontal, so we can just put it directly into Vx. That's the horizontal velocity of the cat. The problem with this one is that it is both horizontal and vertical. And our equations don't like velocities that are both horizontal and vertical. We want either vertical or horizontal. This is the horizontal velocity, and these two are the vertical velocities. We can't deal with stuff that's in between, or both, I should say. Um, and that's not entirely true. We can deal with that. We just have to do something very special. So today's lesson is about vector components. What if you have a vector, which remember is just some quantity that has both an amount and a direction to it? So we've been dealing with that for a while now, velocity, even acceleration. For example, the acceleration due to gravity, it's 10 meters per second squared. That's the magnitude is the number. Well, I should actually show the units are part of that number. And there's the direction. So it's going downward. Velocities, we've dealt with them going right, going left, going up, and going down. So again, we've already been dealing with vectors for a while. So let's get this off of here. Okay, but what if we have a vector that's not right, left, up, or down? What if it's at an angle? What we can do is we can take that vector and break it up into parts. And here's how we do it. I'm just going to retrace this image here. What if we have a vector that goes in this direction? We want to break it up into a horizontal part and a vertical part. So imagine you are here at the start of the vector and you want to get to the arrowhead that's way over here. But the trick is you can only go horizontally or vertically. Start horizontally. So we want to go like we're going this way and go right underneath the arrowhead there as best you can. And let's get some green. Now what we want to do is do the vertical part, and as if you didn't even let up off your pen, like you're still on the paper, just go from there and draw up. And what you should notice is that we've made a right triangle, and I didn't draw it amazingly. This would be a right triangle. Now it's not a triangle. I mean, it is, but it's not. Um, it's a triangle, but it has directions. So remember, those arrowheads are important. They must look like that. Okay. And I realized that my original drawing is not that good. They should be everything should be touching. This should be all the way. So, oh well, can be fixed later. Cool. So we know how to draw it. Take a vector and put it into its x component and y components. Um, to calculate how much they are, this is just using trigonometry, which is easy once we get some going here. So I think it's best just to do an example. Here's the ground. Superman flies at 80 meters per second. So here's Superman, cape. And Superman flies at 80 meters per second at a 48-degree angle with the horizontal. So I'm going to draw it right here. Let's imagine this is his velocity vector. 48 degrees is his velocity vector. And by the way, that's how we show a vector quantity. It has the letter V for velocity, and it has a little arrow above it to show that it is a vector quantity. Sorry, I'm doing this at the end of the day, and I'm not thinking too clearly. 80 meters per second is the vector, and the angle is 48 degrees, is that angle. Cool, and so I want you to imagine he's just going to fly off in that direction. Now, what we want to show, and now I'm going to erase some of this. I'm going to erase Superman as well. What we want to show is again, we're going from here. We're going to start with the horizontal part, which is about right there. Okay, gets rid of it. And now we want to do a vertical part. We're going to call this not the x component, it is the x component. We're going to call it Vx, and we're going to call this Vy naught. Oh, and then I realized I made a mistake here. This is his initial velocity, so that should be V naught. V naught. So that's his initial velocity, V naught. This is the horizontal part, Vx, and the vertical part, Vy naught. Cool. So we know how to draw it. What we want to do is calculate it. How much is it? This is just a triangle. This is trigonometry. And here's the way this works. Has to do with sine, cosine, and tangent. So I'll just briefly write those. These are all ratios of sides of the triangle. So sine is a ratio of the opposite side to the angle. So here's the angle. The opposite side would be this one, over the hypotenuse. The hypotenuse is the long part of the triangle, the longest side. Cosine is the ratio between the adjacent side to the angle. If here's the angle, this one is the adjacent. Adjacent means next to, over the hypotenuse. And tangent is the opposite side over the adjacent side. Now, I could show you how we derive this equation that I'm going to show you right now. It's very easy, but just take my word for it that this side of the triangle is going to be equal to, in this case, it's going to be equal to V naught cosine of theta. Okay, all I've done is I've used this equation and I've rearranged it for the adjacent side. Okay, which, by the way, if you multiply both sides by the hypotenuse, it should be the hypotenuse times the cosine of the angle is giving you the adjacent side. This is exactly what we wrote here. Vx is the adjacent side. This is the hypotenuse, and that's cosine. So there, I showed you how we got that, where we got that from. So we'll put in some numbers. V naught is 80. Cosine, 48. Very important. Maybe put this off on the side. You must be in degree mode on your calculator. If you are in radian mode, you will just get it wrong. So if you're not sure how to put that in degree mode, you can ask me in class. So let's see here. I'm going to do 48 cosine because that's how my computer works, times 80, and I have to do it backwards. 53.53. And for velocity, this is meters per second, which is reasonable for the adjacent side of this type of triangle. If this is 80, yeah, 53.5 sounds right. Let's do Vy naught. Vy naught. So here, I am just using the sine relationship, sine function. Vy naught is equal to V naught sine of theta. So Vy naught equals 80 sine theta, sine of 48. Cool, just like we just did, it's very similar. So I'll put in 48, I'll do sine times 80. Now if you all are using a good calculator, you just type it in. I'm using the weird calculator, kind of similar to your phone, where you kind of have to do things, which I'll say is like backwards. Okay, meters per second. Pretty good. Yeah, cool. Now, this is positive, and this is positive. That just means that Vx, that this is moving to the right, but we never have to show that. And this is just means that it's moving up, but we don't have to show that. If they come out negative, then that's what they mean. They mean that they're moving in those opposite directions. And that is it.